So welcome to the lectures of power system dynamics and control. In the last class, we derived the various equations for voltage in the starter and rotor, and also the flux linkage equations, right? So today we'll continue that one, and also we have started the synchronous machine dynamics in the synchronous reference frame. So why we need to transform to the synchronous reference frame? Already I explained that it is very important because we have time varying quantities with three phase, and those quantities, in fact, when we derive various equations, it becomes more complex and time varying in nature, and it is very difficult to analyze. So therefore we are transforming to a time invariant system, time invariant quantities, so that we can analyze very easily. Okay, the already I discussed this. The synchronous machine dynamics depend on the rotor angle with respect to A-MMF axis, which varies with time. And due to this time varying nature of the parameters, the synchronous machine, it becomes very difficult to analyze the system. So therefore, R.H. Park has proposed a method to transform the time varying AC quantities into time invariant quantities. So this is the transformation matrix, DQ transformation matrix. Already we discussed the values of K1 and K2. And how to choose K1 and K2, we already discussed it. So in this analysis particularly, we'll choose K1 equal to 2 by 3 and K2 equal to 1 by 2. And of course, we can choose K1 equal to 2 by 3 root over and K2 equal to 1 by 2 square root. If we'll choose this, it becomes the power invariant transformation. And when we choose K1 equal to 2 by 3 and K2 equal to 1 by 2, it becomes your magnitude invariant transformation. So we'll prefer here magnitude invariant transformation. So also we have seen when we transform the three-phase current quantities here, already we have seen it, how these three-phase currents IA, IB, IC, when we transform into dq quantity, we'll have Im cos of omega st minus theta s, and Iq becomes Im sin omega st minus theta s, Io becomes 0. So this theta s, if we'll take delta plus omega st, considering the one synchronously rotating reference, which is rotating at the synchronous speed omega s, and then I can write theta s equal to delta plus omega st. And by substituting it, I'll find a time invariant quantity for ID, IQ, right? And that is Im cos delta, that is equal to ID, and IQ equal to minus Im sin delta. So we have seen that here your Im is the magnitude, which actually it is the magnitude in the three-phase quantities also, time variant quantities also, right? And also here another advantage we are getting is Im is equal to ID square plus IQ square. Both ID and IQ, right, can be used to find Im itself, right? And IO becomes 0. So now if I'll transform the voltages, starter voltages, VA, VB, VC, then I can write VD, VQ, VO will be equal to TD, QO, VA, VD, VB, VC, right? Or I can say that VA, VB, VC will be equal to TD, QO inverse, VD, VQ, VO, right? Similarly, I can transform the flux linkage equation, lambda D, lambda Q, lambda O will be equal to transformation matrix TD, QO into lambda A, lambda B, lambda C, or I can say lambda A, lambda B, lambda C, the flux linkage in the three-phase system will be equal to TDQO inverse into lambda d lambda q lambda, right? And where TDQO inverse, if we'll take the inverse of TDQO, where K1 equal to 2 by 3 and K2 equal to 1 by 2, we'll find it becomes very simple matrix cos theta s minus sin theta s 1. Then second row elements are cos theta s minus 120 degree minus sin theta s minus 120 degree 1. And third row elements are cos theta s plus 120 minus sin theta s plus 120 and also 1, right? So the similar matrix we are getting except few changes. So now if we'll see derive the complex power, instantaneous complex power. So I can write in the three-phase system, of course, S will be equal to S I can write VAIA plus VBIV plus VCIC, right? And I can write this in the matrix form, that is VAVVVC transform into IAIBIC. When I'll multiply this, I'll get this, right? VAIA plus VBIV plus VCIC. Now, applying the transformation, so VAVVVC I can write TDQO inverse VDVQVO, that is whole transpose, and IAIBIC I can write TDQO inverse IDIQIO, right? Then by taking the transpose, I will get VDVQVO transpose, TDQO inverse transpose, TDQO inverse IDIQIO, right? And then I'll find just by multiplying this, I'll get these values, right? 3 by 2, 3 by 2, 3, and other off diagonal elements will be 0. So therefore, it will be VDVQ transpose, VDVQVO transpose in this matrix where 3 by 2 is multiplied with a unity matrix or identity matrix into IDIQIO, right? So just by multiplying it, what we'll get? 3 by 2, just if we'll expand this expression, I'll get S equal to 3 by 2 VDID plus BQIQ plus twice of VOIO. Right? Here, if we'll expand and multiply it, I'll get this equation, this expression, and which is in fact is equal to VAIA plus VBIV plus VCIC. Right? So therefore, what is not true here is the power. Power in the three-phase system, that is time invariant system, is VAIA plus VBIV plus VCIC, which is not equal to VDID plus VQIQ plus VOIO. This is equal to 3 by 2 times VDID, VQIQ plus twice of VOIO, right? So therefore, it is not power invariant transformation. So if we'll choose K1 equal to 2 by 3, square root of 2 by 3, and K2 equal to 1 by square root, then of course we'll get, you can check it once by applying this, choosing K1 equal to 2 by 3 square root and K2 equal to 1 by square root. You can find this power expression once again, and you will see that it will be VAIA plus VBIV plus VCIC will be equal to VDID plus VQIQ plus VOIO. Obviously, you will find this expression. So this is the power invariant transformation where the power expression, instantaneous power expression in ABC system or three-phase system will be equal to the instantaneous power at the DQ frame reference, right? Now, if we'll see the VDID, VDVQVO, and I'll just apply the transformation to VAIA V to the equation of to the terminal voltage equation of the stator. If I'll just apply this, and I'll find it that it will be just I'm telling here writing the expressions. So previously it was VA, VV, VC, which is equal to which is equal to your RS minus RS, it is minus sign, into IA, IB and IC, right? Plus here your dy dt of lambda d, lambda q and lambda o, right? This is your expression. Now if we'll transform this whole equation, so this will become what? TDO inverse, TDQO inverse. I can write it as TDQO inverse VD, VQ and VO, and this will become minus RS, RSO, O, RS. This will be same IB, IC. I can write TDQO inverse ID, IQ and IO, right? Plus, similarly, I can write this. This is already there. This is lambda A, lambda B and lambda C, sorry. This is lambda A, lambda B and lambda C, right? So now I can write it as lambda A, lambda B, lambda C. I can write it d by dt of TDQ inverse into lambda D, lambda Q and lambda O, right? So now if I'll just multiply TDQO both the side, both left and right hand side, I'll get this expression, above expression, right? Whatever we are seeing here, I can get this expression, right? So therefore, I can say that just by multiplying TDQO, I'll get this expression. VD, VQ, VO will be equal to minus TDQO, RS, the diagonal elements and off diagonal elements are 0. Then TDQO inverse, ID, IQ, IO, TDQO, dy dt, TDQO inverse, lambda d, lambda q, lambda o, right? Now if I'll multiply this equation, I'll get, of course, if I'll take RS common, it is a identity matrix. So TDQO, TDQO inverse will also become identity matrix. So therefore, identity matrix again multiplied with RS, it will give me RS into RS. Again the same matrix will come. The diagonal elements will be RS, 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 and off diagonal elements will be 0, 0, 0. And it will be multiplied with ID, IQ, IO. And here, because we have a derivative term of this expression, right? The whole derivative of this expression. So therefore, I can segregate because this is the multiplication of two factors. So I can write the derivative by applying the multiplication rule in the derivative. I can find so TDQO into dy dt of TDQO inverse lambda d, lambda q, lambda o plus TDQO, TDQO inverse. Again, it will come out and dy dt of lambda d, lambda q, lambda o, right? Now, just by taking the derivative, I will get this expression, right? Here, and multiplying TDQO, I will get this expression 0 minus omega 0, omega 0, 0, 0, 0, 0, right? Multiply with lambda d, lambda q, lambda o. And this TDQO, TDQO inverse will become identity matrix. So therefore, only term is remaining dy dt of lambda d, lambda q and lambda o, right? Now, this is your expression for VD, VQ and VO, right? Now we'll see the transformation in the flux linkage equation itself. So stator and rotor equation in terms of dQO, we can write here the VD VQ VO will become from this expression, from this equation we'll find as this, right? So it will become BD will become equal to minus RS ID minus omega lambda Q plus d lambda d by dt. Then VQ will become minus RS IQ plus omega lambda d plus d lambda Q by dt. VO equal to minus RS IO plus d by dt of lambda O. Okay. Then your VFD and V1D, V1Q, V2Q, they are already in the DQ frame, right? Because they are the constant DC quantities and they are in the DQ frame of reference, because the rotor is rotating at under steady state condition, the rotor is rotating at the synchronous speed, right? So this is how we can write the equation of the rotor voltage equation will remain same as it is. Then your lambda d, lambda q, lambda o. Now the flux linkage equation similarly I can write and I can apply the transformation, dqo transformation to the three-phase flux linkage equation, right? So after applying the dqo transformation, I'll find lambda d, lambda q, lambda o will be equal to minus tdqo LSS into tdqo inverse IDIQ plus tdqo LSR into IFD, I1D, I1Q, I2Q, right? Similarly, the flux linkage equation of the rotor side will remain same, except the ABC quantities or three-phase quantities. Here it was IA, IB, IC, which I can write it as TDQO inverse into ID, IQ, IO, right? And other quantities will remain same, right? Now I can find just by expanding this first equation, lambda d, lambda q, lambda o, I can write this expression, just expanding and multiplying, I will find this equation will become lambda d, lambda q, lambda o will become 3 by 2 LAO plus LAP 0, 0, 0, 3 by 2 LAO minus LAP 0, 0, 0, 0, right? Multiplied with ID, IQ, IO, and again your second term will by multiplying TDQO with LSR will get this expression, right? LSFD, LS1D, 0, 0, 0, 0, LS1Q, LS2Q, all other quantities are 0, right? Now if we'll take 3 by 2 LAO plus LAP is equal to LD, and 3 by 2 LAO minus LAP will be equal to LQ, then I can define, then if I'll substitute and also define LMD equal to LD minus LLS, LMQ will be equal to LQ minus LLS, where LLS is the leakage inductance, the starter, okay, and LD is the net inductance and LQ is the net inductance, the Q axis, and LMD, LMQ, they are the mutual inductances across D axis and Q axis. So here LD and LQ are inductances along D Q axis corresponding to the total flux leakage. However, there will be leakage flux in the slots at winding ends and zigzag paths between stator and rotor tooth faces. To account for this leakage, a leakage inductance LLS is considered and is assumed to be same along D and Q axis. The mutual inductance along D and Q axis is represented as LMD and LMQ. So now if I'll substitute, I can find lambda D will be equal to Instead of LD, I can write LLS plus LMD from this equation, right? So therefore, by substituting this, I can write lambda D equal to minus LLS plus LMD into ID. Other terms will remain as it is, LSFD IFD plus LS1D I1D. Similarly, your lambda Q will become equal to minus LLS LMQ IQ LS1Q I1Q plus LS2Q I2Q. Of course, lambda 0 will become 0 because all the rows corresponding to the lambda naught is 0, right? So it will become 0. Now I can write the expression for LFD, L1, sorry, lambda FD, lambda 1D, lambda 1Q and lambda 2Q. They're remaining as it is, except only one transformation matrix is multiplied in one of the terms. So after multiplying, we'll get the expression of lambda FD, lambda 1D, lambda 1Q and lambda 2Q. So it can be observed from these equations in DQ or reference frame that the mutual inductances, though now are not a function of time, are not the same. You can see here the mutual inductances are not same. It is actually different. So in order to make all the mutual inductances between the windings equal, for sake of reducing complexity in analysis, a proper power unit system can be chosen. So by choosing the power unit system, we can make these mutual inductances equal. This power unit representation, what is this power unit representation? Because we have written first the swing equation that also was in power unit representation. So therefore, other equations must be in power unit. So therefore, we'll now start transforming to the power unit system, because whatever equation we are writing, it is in the volt current in ampere form. So we have to change it to the power unit representation. So let the starter line to neutral RMS voltage be taken as the base voltage, and the generator three-phase apparent power be taken as the base power. Okay. Then with these two bases, other base quantities can be defined as given below. We considered the starter line to neutral RMS voltage be taken as base voltage, VRMS, right? That is line to neutral voltage, and the three-phase apparent generator power S, that is also considered as the base power. And considering these two base values, we'll find other base quantities, right? So this V base RMS line to neutral in kV, and S base, that is rated MVA, 3 V base I base, right? So now I can find I base from here. So I base will become S base by 3 V base, right? So yeah, that is in kiloampere. Now Z base will become V base by I base, that is in ohm, right? These are base quantities. Then omega base will become omega S, that is equal to 2 pi f electrical radian per second, where f is 50 or 60 depending upon the system. And your omega m base will become 2 by p of omega base, because this is in the mechanical radian per second. Okay. And your L base will become Z base by omega base, and your lambda base will become V base by omega base. So how is L base equal to Z base by omega base? Because L base is, we can write this as, uh, of course it is coming Z base omega L equal to Z, so obviously it will be Z base by omega base, right? Similarly, your lambda base will be V base by omega base, and T base, the time base quantity, will be 1 by omega base second per radian, right? So these are the base quantities. Okay, so we'll stop here. We'll go ahead with this per unit system. After transforming, we'll represent the per unit representation of the system. Then we'll gradually go ahead in the modeling of the synchronous generator. So This is how we'll stop here. Then next class we'll discuss again. We'll start from here, the modeling of the synchronous generator. We'll stop here. Thank you very much.